Section 10.10 is on page 648. It talks about applications of Taylor series. And in here, they're talking about specifically binomial. Binomial series look like this. One plus x raised to a power. So, we're going to derive this way. You don't have to do it again. So watch how this works. If I let f of x equal 1 plus x to the n. Anytime I want to find a series representation for a new function, I use Taylor, Maclaurin if they don't specify. So this is going to be what? F of 0 plus f prime of 0 x to the 1 over 1 factorial plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 times x cubed over 3 factorial. Maybe a couple more just to be confident of what this is. And there it is. This goes on. So, what I need to find those derivatives, evaluate them at 0. I need to find what f of 0 is, f prime of 0 is. So, these values are fixed. That is, the x to the 1 over 1 factorial is going to always be there. The x squared over 2 factorial is going to always be there. The x cubed, those are fixed, they're not changing. The only thing that's going to change is really the derivative evaluated at 0. So I'm going to go on the side and figure out what this is. So I know that f is 1 plus x to the n. If I let x equals 0, I will get 1 to the n, which is 1. And if I take a derivative, I need a space. If I take a derivative, wouldn't that be m into 1 plus x to the n minus 1? And when I plug that in, that will be simply m times 1, which is m. F double prime will be m into m minus 1, 1 plus x to the n minus 1. And if I plug 0 in, how about the third derivative? Isn't that m into m minus 1 into m minus 2? I'll slow down. Times 1 plus x to the n minus 3. And wouldn't that be m into m minus 1 into m minus 2? So we hopefully see the pattern. This is 1, this is m, this is m into m minus 1, this is m into m minus 1 into m minus 2, and this is m into m minus 1, m minus 2. Yeah, it seems like too many. These things go fast. Into m minus 3. Now, something I want to point out. This is 1 plus m x to the 1 over 1 factorial plus m into m minus 1 x squared over 2 factorial, let me write this clearly, plus m into m minus 1 into m minus 2 x cubed over 3 factorial, and the list goes on. The deal is, somebody work this out and want you to avoid all of this work. Meaning, if I see anything that looks like 1 plus x to the n power, instead of me doing all of this work and listing all of those and listing all of this, I could list this right away. And I save myself all of this work and all of this work, and I jump straight to what this is saying. Meaning what? Meaning, if I see that f of x equals 1 plus x to the n, instead of doing the Taylor series and doing all of that work, I could say that's 1 plus m times x to the 1 over 1 factorial plus m into m minus 1 x squared over 2 factorial plus m into m minus 1 into m minus 2 x cubed over 3 factorial, and the list goes on. And by doing that, I have already skipped all the work I just did on this problem. Example. An example I'd like to look at, and here it says find the first 4 terms of the power series, just the first 4. What does that mean? I need to go one more than this. And if I look at this problem, now do you see that this looks, do we agree that this looks just like this, and this is on page 655. So wouldn't you say this is 1 plus m? Now, do you know what m is? And isn't x just x? M times x to the 1 over 1 factorial plus m. What's m minus 1? X squared over 2 factorial plus m. 1/3 minus 1 is negative 2/3. Negative 2/3 minus 1 is negative 5/3 times x cubed over 3 factorial. And they want one more. M into m minus 1 into m minus 2, so subtract 1. Subtract another one, that's negative 8/3 x to the 4th over 4 factorial. So I could say 1 plus x raised to the 1/3 is 1 plus 1 over 3x minus 1 over 9x squared plus 10, not 10. This is 3 times 2 times 1. Those cancel out, right? So that's going to be 5 over 3. Is that 81? Minus, this is 4 times 3 times 2 times 1. So the 4 and the 2 cancel that completely. You're left with a 10x to the 4th over, and let's see, what do you have? 1, 2, 3, 4, 5. You could write 3 to the 5th, I really don't mind, or 243. So if you want to leave those in powers, that's fine. There it is. So by recognizing it's a binomial series, I am saving myself the work of Taylor, which is tedious in this. When you take a derivative of this, a second derivative, a third, these become very tedious very quickly. Let me look at another problem. There's one. They want us to write this 4th degree. Well, that's going to be 1 plus mx to the 1 over 1 factorial. And this formula doesn't change if it is binomial. And it turns out to apply on a lot of problems. So it has a lot of applications. That's why you're learning this. And one more. And there it is. That's pretty much the problem. That is 1 plus m is 4, and x is really replaced by negative x over 3. So substitute accordingly. 4 times negative 4/3 to the 1 over 1 factorial plus 4 times 1 less negative 4/3 squared over 2 factorial plus 4 times 3 times 1 more negative 4/3 cubed over 3 factorial and 4 times 3 times 2 times 1 negative 4/3 cubed over 4 factorial. I meant to the 4th power. So if you pay attention, you are. Good job. So I could say this is 1 minus 16 over 3 plus 2 times 1. This cancel with that 2 times. That's 16. 16 times 3 is 48. Oh, I'm sorry. Take that back. I'm going to slow down a bit. This is 2 times 1, so 2's cancel out. And this is 9. This cancel. You know what? I'll write it in 2 steps. That's easier. So that is 2 times 3 times 16 over 9 plus this is 3 times 2 times 1, so those cancel out. That is 4 times negative 64 over 27. And the last piece, this is 4 times 3 times 2 times 1. Those cancel with those completely. That is 4 to the 4th. What is that? 4, 16 times 16. 256, I think, over 3 to the 4th, 81. So there it is. Again, a couple of steps, not a problem, no need to rush. 1 minus 16 over 3 plus 32 over 6, 32 over 3, my mistake, minus 256 divided by 27 plus, I thought this would be bigger, but I could be mistaken, 256 divided by 81. I thought the top always goes up. I might have made a mistake. Let me double check. Oh boy, I see what the mistake is. I'm sure you guys saw it way back. Again, one of the problems with not having this in class, this is not a 4, it's an X. Right? That was an X, so that's an X. Oh man, this is something. So this is 1 minus 4/3 X. Here, this is 2 times 1, this cancels with that 2 times. So this is going to be 3 times X squared over 9 plus 4 times 3 times 2, and this is 3 times 2 times 1, those cancel out. 4 times negative 27, negative X cubed over 27. And this does cancel out. Plus X to the 4th over 81. So this is 1 minus 4 over 3X plus X squared over 3 minus 4X cubed over 27 plus X to the 4th over 81. That would be the polynomial that would approximate this power function around 0. As long as you stay around 0, you're fine. Now I'm going to stop here and continue this in a second.